Yo, 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 this is Mr. O, and today we're going to learn about finding the domain of a function. Okay, we know the domain or the input or the x values in a function, but there are cases that we cannot have or we have a restriction on identifying the value or the defining a domain of a given function. So let's start now here. Find a domain. If you're given this reciprocal function f of x equal to 1 over x, we cannot basically the question is what are the possible values of x we can have here. We can have a value of x which is equal to 2 because if you plug in the 2 there, it will give us the f of x will become 1 half. If we put there a f of negative 3, our answer will be negative 1/3, right? But what if we put an f of 0? Are we, is this possible? If you put 1 over 0, the answer will be undefined. So therefore, since it's going to be undefined, we cannot have a 0 value for x. We can have a positive 2, 3, 4, 5. We can have a negative 1, negative 2, negative 3, negative 4. But we cannot have the value of 0 because the denominator will be equal to 0. In other words, we're finding where it can't work, where it will become undefined or not possible. So in this case here, for the f of x equals 1 over x, the domain here is all real numbers except x cannot be equal to 0. That will be your domain for this function. What about if I add, let's say, f of x equal to, let's say here, a 5 and then an x plus or x minus 3? What could be the value of x here? Again, same thing what we did here. You grab the denominator. Denominator here was x, so we set that equal to 0. On this case here, on this example, the denominator is x minus 3. We set it to not equal to 0, and we try to solve for the x here by adding 3 here. That will give us x cannot be equal to 3. In other words, the domain of this function is all real numbers except x cannot be equal to 3. That's the restriction. That's the domain. Why? If you put the 3 here to the value of x here, so your f of 3 will be 5 over 3 minus 3, which we know 3 minus 3 will be 0, so it will give us 5 over 0, or it will be undefined. So we cannot have x equal to 3 for our domain, but the any other number will work. Okay, and that's for the reciprocal function. What about if we have a square root function? A square root, we know that f0 is, square root of 0 will give us 0 because 0 times 0 is 0. If we have f of 1, that will give us square root of 1, which will be a 1. A 4 will give us square root of 4, which will give you a 2. But look, if we have f of negative 4, it will give us square root of negative 4. If you try to punch in your calculator a negative value inside the square root, it will give you an error or it will be undefined. In other words, you cannot have a negative value inside your square root. So you cannot have a f of negative 1, f of negative 9, or any other negative will give you undefined. In other words, to make the story short, any radicand is the expression inside the radical, has to be greater than or equal to 0. So what we do, we grab the radicand and set it greater than 0, and that will give us our domain. So in this case here, the domain here is all real numbers that are x greater than or equal to 0, including 0, because square root of 0 will be 0. So if we're given as f of x is equal to the square root of x minus 4, what we do, we grab the radicand, which is x minus 4, set it to greater than or equal to 0, and so for the x. Add 4 on both sides, add 4 on both sides, and you can see that x must be greater than or equal to 4. So our domain is all real numbers that are greater than or equal to 4. To prove it, if we pick a number that is not greater than or equal to 4, let's say 3. If we pick 3, f of 3, which is not greater than or equal to 4, it will be a square root of 3 minus 4, which will give you f of 3 is going to be square root of negative 1, which will be undefined or imaginary number. It's not real, it's not true. That's why you have to follow the restriction of the domain that it has to be 4 or more or greater than 4. Okay? Let's combine them. What if we have both the squared function and the reciprocal function being together here? Okay, so let's start now. So here we know that the first function, the f of x, is x minus 2 divided by square root of x plus 1. Again, the restriction for the denominator cannot be equal to 0, cannot be equal to 0. At the same time, inside the radicand, that has to be greater than or equal to 0. If you notice, this is greater than equal to 0, this one is greater than equal to 0, and the other one has to be cannot be equal to 0. In other words, I cannot pick this restriction because this the line under the greater than means equal. So in other words, what we need to do here is grab the denominator, the radicand only, x plus 1, and has to be only greater than 0. Take note, it's only greater than, not equal, because if we set it equal, then we're saying the denominator, it's okay to have 0 value. We cannot. Remember the reciprocal. Remember this cannot be equal to 0. Okay, so minus 1. So therefore, x must be greater than negative 1, and that is your domain for this f of x. Okay, next, h of x. Okay, remember the denominator cannot be equal to 0, so I'm just gonna grab the 3 minus x, set it to not equal to 0, right? So we'll have here add x on both sides, add x on both sides. So therefore 3 cannot be equal to x. So the 3 cannot be equal to x. Very simple, right? And look at the square root. What is the rule for the square root? Has to be greater than or equal to 0. So we have two problems here. So x minus 8 greater than equal to 0. So add 8, add 8. So therefore x must be greater than equal to 8. Okay, so anything from 8 onwards. So the answer is from all the numbers except x cannot be equal to 3. Also, union or another one that has to be x greater than equal to 8. Imagine in a number line, if this is my 0, that's my 3, this is my 8, all the numbers will be allowed from the negative, from the left side of x, except 3. So there's an open hole here. And then, uh, and then this one here. Okay, hold on. So everything here for the pink one. Okay. While for the x greater than equal to 8, this is the 8, close, going that side. Which one do you think that they overlap? They overlap right here on this yellow one, right here. That means I cannot have anything smaller than 8. Because think, if I choose 4, okay, I choose 4, it will give me a 4 minus 8 right here. It will be imaginary, it will be undefined. So in other words, the final answer here would have been all real number that are x greater than equal to 8. That's the only answer. Not including x cannot be equal to 3 because 3 is smaller than 8. It says here under the other restriction that x must be greater than or equal to 8. All right. And next one here, or last one here, g of x equal to 5 over x squared minus 4x. What I've noticed, my denominator here is a quadratic. So x squared minus 4x is equal to 0. How do we simplify this? We know that both of them can be they have x's and can be factor out. So x minus 4 is equal to 0. And we know that the x here cannot be equal to 0, so I can put a slash there. And using the zero factor property, it says there x cannot be equal to 0, and then x minus 4 cannot be equal to 0. Solve for x. Here, the x value is already by itself. Here, you add 4 on both sides. So therefore, x cannot be equal to positive 4. So now here, putting them in a number line, This is the 0, that's the 4. You can have any number on the left side of the 0, the negative value, except 0. You can have any number between 0 to 4 except 4. Boom, anything on the blue will work. So the answer here would be all real numbers except x cannot be equal to 0 and x cannot be equal to positive 4. That is the complete answer. Okay. Alrighty. I hope you learned something and finding the domain using this different kind of functions, square root, reciprocal, and combine. As always, kaboom.